let's see what is Profis Engineering Suite. This is an cloud-based connection design software. It is recommended by the HILTI construction company. It is generally used for the design of the base plate in a very, you can say, an efficient and a frequent way. You can find this particular cloud software by searching onto the Google, just like you can type HILTI Profis Engineering Suite, and you're going to land on this page. Now, this page tells you all the basic things that this particular cloud-based design software can do. It can design the base plate analysis as design as per the Indian standard I-800. It can do the concrete to concrete design. You can take out the reports and all that. You can even import the loads from any of the structural analysis software that are right now available in the you can say market, that is Etabs, Stud Pro, or whatever you want. I let you know in a moment that how you can do that particular thing. Okay, you can go into the other portions. You can use this particular web software to do the anchoring to the concrete. You can do the post install rebar. You can do the concrete overlay. Okay, and also you can do the anchoring to the masonry. Now, this web-based tool is available in 4 type of licenses. The first one is free, which can be used by the educator, researchers, and the students. The other one is going to be the premium, that is going for the individual. Then it is going to be for the mid-sized companies and then enterprises. Right now, I'm going to elaborate here the standard version. It is having almost everything that one needs to learn to get started. Okay, you can see this bottom chart, comparison chart, that in standard what you are going to get, and the premium and premium floating and the enterprise, what more you are going to get. Okay, so some of the things are not there in the above versions, like project sharing, the customizable reports and all. The Eurocode design is not there in some of the is not there in the free version and all. So like that, you can do something here and something there. The integration with third-party analysis is not directly available in the free version, but you can do the copy paste that I'm going to let you know into a while. And these are the kind of plugins that are not available in the free version, but you can do that in the premium version. So let's get started how we can do this. So here onto this page, that is Profis Engineering, I'm going to share this link in the description below. You can just click on this start free trial. You can sign up here and you can get your software going on. Okay, so this is totally cloud-based. Now this is the side we are going to get to know. We are going to first register. So just click on register. Now it is going to ask you a work email address. If you have a Gmail, it will work fine. Okay, so I'm just taking a temporary email here. I'm just going to copy it and I'm going to paste it here, and I'm going to create a password for it. Okay, you need to check the minimum requirements for the password. So I'm going to create a password for that particular thing. Okay, you can choose the country. I'm going to choose India for this particular time. Okay, and let's hit continue. Now it is going to send a, you can say, an OTP or kind of a 6-digit code to your that particular email address. So we are going to take out our email address from this temporary email, and there is an one-time code. So we are going to paste it here. Now it is asking for a password that you can generate, that new password you can generate. Let's suppose in some cases it is going to take you to the next step, that is the main registration page step. There it can take you. Now the moment you are going to get here, it is going to let you know that your trial expires in 30 days. I have skipped 1 or 2 of the steps previous to this particular screen, because it was asking all of this thing, that is your street address, your company's name, and all of these things. You can just put all these things and you are going to land on this page, that is your trial is going to expire in 30 days and all. So we are going to dismiss it. Now there are right now 4 things that a free user can use, that is anchoring to concrete, that is the, you can design the base plate, that is what I'm going to demonstrate right now. You can use the anchoring to masonry, the concrete overlay, and the post install rebar. So I'm going to use the anchoring to concrete. It is going to be it is going to use the Indian and European design. So I'm going to click on it. Now it's a web-based tool, so make sure you have an good internet connection, and at least you have a Google Chrome or Brave software like that, so you can use it. Okay, so this is the whole screen in front of us right now. There are tools onto the left hand side. You can select it from here. The first one is the home, that is going to take you onto the home screen, and then after that, the more you work on it, there are going to be the favorite ones according to the software or according to your browsing experience. So these are going to be my favorite inputs. Then you can see here that is our smart design, and to bottom it is having a base material, and then so on, reinforcement in that base material, then the things about anchor plate, then about the anchor you are going to use, then about the profile, that is what kind of section you are using right now, and then the last load combination. Onto the bottom, you can see we have an load input values. You can here put the values here. First of all, check the axes. The x and y are the horizontal one, and the z is the vertical one. So v, x, and vy are the forces in x and y direction. N is here the normal force, that is in the z direction. Then there are the movement mx, my, and mz. Okay, so you need to put the values here. You can name this combination any of like you want. There are input custom factor load. You can put the loads factorly from. I'm going to let you know about these both of these things. These are the main things that we usually take from the other softwares like structural analysis software or any of the Etabs Pro. You can take the loads from there and you can directly paste on it here. Okay. Onto the right hand side is the all the calculation process. And the moment you are going to hit calculate, it is going to calculate and going to see that the utilization ratio is how much, or the stresses is how the connection is getting passed or not, and all those things. Okay, so onto the top here are some things that you can use to alter this UI. Okay, this user interface, or you can say the thing that you are seeing right now in front of you. You can tackle this thing. You can change this thing from all of this option. I'm going to let you know about this in a moment. Okay, so with the left click and drag, you can just rotate it, and with right click, you can pan it around. With the mouse wheel, you can zoom in and zoom out. Okay, so like that, you can do all of things. So let's try to change it, and let's try to understand what kind of feature this cloud software provide us. Onto the left, let's start from this base material. That is the base material is that concrete. So it is a normal concrete. Whether it is a cracked or not, you need to check it or uncheck. Now it is asking for the grade. That is right now it is opened as per the Indian standard. So I'm going to take M30 concrete. So M30 concrete is going to have a 30 Newton per mm square of the cube strength at 28 days off. Okay, so then there is going to be the temperature. What is the temperature you can input. Now comes the main thing, that is the concrete thickness. How much thickness is this? So you can right now keep as it is, or if in your case if it is something else, you can try with that particular thing. Now these are edge distances. Edge distances means the edge distance means the distance of the plate from the edge. Okay, in the positive x direction it is 100 mm. You can see it is the x direction, so this is going to be 100. You can see my cursor is right now hovering over this particular dimension. You can change the dimension from here also into this box also, or directly left clicking on this and you inputting value any other. Like I'm going to input 150 and I am going to hit enter. It is going to update like that in the real time. Okay, now onto the negative x. Negative x means this negative from this side. It is kind of a wavy in view. This wave view means it is at infinite distance. That is, the calculation is going to take infinite. Oh, okay, so the cube is there, but generally in real time it is not like that. So we can just uncheck it and we can provide some values here. Okay, so let's provide 150, same as the positive x, and do it for the y also. Let's provide the same, try to provide the symmetricity here. So 150, and onto the negative also, that is 150. Okay, the moment you are going to enter the things, it is going to update it into the real time. Okay, so you can see it is all 150, 150, 150, 150. You can do it from here also by clicking here and changing the values. Okay, now let's come on to the downward. The thing here is installation condition, that what is going to be the drilling type. It is going to be hammer drilled or the core drilled or like that. Generally in India, in our site condition, we generally use the hammer drilled, so you can do that particular thing. But in your case, you need to check it out. What is the hole type is going to be? It is a water saturated. At the time of drilling, you are using the water or like water filled holes like that. I'm right now using a dry concrete. It is a dry drilling. There is a torquing method also. So how you are going to tighten this, you can say the fasteners, that is manually torque wrench, or there's an adaptive torque system. So right now we generally use here in India, that is manually torque wrenches. So this one is done. Let's move on to the next step, that is reinforcement. The concrete is having how much of reinforcement? Is it a wide reinforcement or a dense reinforcement, or is it none reinforcement? There is no reinforcement. I'm going to click a wide reinforcement. It's kind of a wide reinforcement. You can click on edges, that is onto the edges. It's a straight reinforcement or straight and closely spaced stirrups are there. You can choose according to your design, or you can start with something and you can then change it as per the results. Now let's move on to the third step, that is the anchor plate, which is going to be the main thing. That is this anchor plate property. It can be rectangular provided here. It can be circular also. It can be like kind of a rhombus also, and you can edit this also from this particular thing. There is an option of ledger angle right now, that if I'm going to click on it, there is only going to be one angle here. Okay, you can do that particular thing also. I'm going to stick with right now the simpler one, that is the rectangular one. If you're going to click on this WLT option, you can change the width of this particular plate. Let's keep this 300, length let's keep 300, and thickness let's keep 20 mm, and I'm going to click save. It is going to update in real time. Okay, so you can do that particular. Now, the moment I have changed the plate, the predefined anchors are now out of the plate, so we need to adjust them. Okay, before doing that, you can also change the material here, that is the grade. So I'm going to use right now, that is E450. Let's see the D grade. So it is going to take like that. Now it has we have an option of standoff here. You can sometime the anchors are given a particular spacing between the concrete surface and the fastener washer, you can say. So if you have a standoff, you can define it from here. If you also have done the grouting, you can also choose this last option. I'm going to stick with this, that is no standoff. You can rotate this anchor plate by these two options, like 90° or whatever. Right now we are having symmetrical plate, so it is not going to look like that. So in anchor plate thickness, you can type the thickness. This can be done from here also and here also. Okay, now let's go for the fastener. Now this is in case of fastener, the HILTI, this software is provided from HILTI, so that's obvious that HILTI is going to promote their anchor. So you can click on this family, and there are plenty of anchors right now available here. Right now I have used this HST3 onto the field, so you can click on it and you can use that particular one right now. Okay, so this is kind of an fastener that we generally use. So it's a type HST3, and the size is going to be, let's suppose M16. M16 means the 16 is going to be the dia. Okay, the embedment depth is going to be 65 or 85. You can type and you can check around it that which one is getting passed. And these are the profiles that one anchor you need, or the 2 or 4 or 5, like that. So if I'm going to click on 4, it is going to automatically embedded those 4 you can say rivets onto the same plate. Okay, it is not going to be like outward onto the outside of it. It is going to automatically detect, and it is going to provide a minimum pitch there. So if it is going to fail, then we can change the pitch. You can also use the 6 one, that is we can use the 6 and all, and you can do this. You can add it also from this particular position, so you can do that also. We have a plenty of, you can say, combinations provided here. You can use any of them, and you can check if your design is getting passed. You can rotate them from here. You can make them unsymmetric, you can make them symmetric. I'm going to make them symmetric, so it is going to be like that. Now there is an option of installation that you are going to fill holes or not, so we are going to keep as it is. So we are not doing right now. We are just taking a simple pattern of just 4 anchor bolts, which are M16 in dia, and these are at the corners. Okay, now let's move on to the profile. The profile is the main thing, that is the column which is resting over this base plate is of which dimension. So right now it is an standard light beam. You can click on it. You can change from other standards. You can use the other standard from here. I'm going to use an standard wide beam, and I'm going to use any of the profile. From profile you can choose from here. So you can take out the any profile from this chart, and you can also define the material according to the codes that you need. Okay, I'm going to hit apply. So these are going to be like that. You can choose the eccentricity here. Eccentricity means the distance between the face of this flange and the edge of, you can say, the plate. So I'm going to keep right now as it is, like the constant one. You can also rotate them. Just see, you can just rotate the profile in this 90° and like that. Okay, this is the main thing, that is web weld location. The weld at the web is going to be like what? It is going to be double-sided weld. So I'm going to click on double-sided weld. You can see there's going to be weld. You can provide a thickness of the weld. I'm going to provide it like 6 mm, and these are the web weld length that you can also provide. For the flanges also, I'm going to use the double welded sides, and I'm going to use the 6 mm of flange weld thickness. Okay, now there is an option of stiffness here also. If there is a heavy, if there any heavy movement coming onto this column, you can just change, you can use the stiffness here. There are plenty of options. We are going to click on it. You can see there are going to be stiffness onto the flange and web side both. Onto the second, you can see onto the only flanges side, or into the web supporting sides, there are going to be flanges, and in this case only on the flange side. So you can click on that. I'm right now not using stiffness. You can do it on in your case. Now the profile has been done. Okay, on to the last, what you have to do, you have to use the loads. Okay, one thing again, I'm going to tell you that you can change all of this dimension from this particular view also. just by clicking them. These are the loads. You can see there's an axis, x-axis. This is the 10 of the normal force, and the 0 of a moment is right now here. Onto the normal, we have 10 kilonewton of force and a 0 moment. And onto here, you can see onto the y-axis, there is a 0 moment and forces. You can change them directly from here also. It is going to reflect at the bottom. So I'm going to click on it, and I'm just going to write like 11. Okay, so it is going to update it like that. Onto the top, I'm going to click 12.5. So it is going to update it. Let's make it a minimum fun just to make the calculation simple. I'm just providing an vertical moment, vertical force of like 12.5 kilonewton, nothing else. And there is an 1 kilonewton of force in the y direction. Okay, let's suppose there is a no moment. You can input all these values here. Okay, so onto the load combination calculation setting, you have to fix here that what kind of calculation system you are going to use. So we have two options right now, that is rigid plate analysis and the CBFEMS analysis, component based FEM analysis. You can choose this one, and onto the advanced setting, you can choose all the other technical details. Okay, so after that, there are the load types. That first one is the static or quasi-static design load that we are going to use right now. You can also do the seismic loads here. You can also do the fatigue and the fire testing. I'm going to stick with right now the static or quasi-static. You can do the design load or the characteristics load. I'm going to input the design load here. Now the design method is based on what your European standard or the SOFA or ETA here. I'm going to use the EN 1992 base system, and concrete and compression is going to be designed according to IS 800 section 7.4, or you can use the 446 section 34.4. Okay, now these are not available right now. That is Global and the Stud Pro, because it is going to be in the premium version. So you can do that. When the things are going to get completed, you can just click here onto the right hand side, that is calculate, and check your all the results. But before doing that, I'm going to let you know that how you can input the loads directly from Stud, or you can say the other softwares. So here's an option that is import factor loads from a spreadsheet. If you're going to click on it, you can paste it here, all the forces. Okay, you can directly paste it here. So I'm going to let you know how you can do this particular thing. So you can see it here. I have taken this load from one of my structural analysis software. You can find out all of this reaction from any of the softwares, and it is going to be represented in different format. But you need to understand that what are the global accesses for your structural analysis software, and you need to also know that what are the global accesses for this HILTI Profis Engineering Suite. So you need to check both of these things. So the FX, FIF, and FZ are the reactions in XYZ are inputted here, and the movement in XYZ are done here. Like for example, if I'm going to tell you about that is the Stud Pro. In the Stud Pro, the coordinate axes are a bit different than the, you can say, this Profis. In Stud Pro, the X and Z are the horizontal one, and the Y is going to be the vertical one. Okay, so but if you are going to see our that is Profis, the Z is going to be the vertical one. So we need to exchange Y and Z here. So I'm going to exchange this Y and Z here. So I'm going to take X into the Z, and I'm going to take Z into the Y. So like that, yeah, that why I'm doing this, I want you to know that this create a very big difference. Okay, so right now we are concerned with this FZ. So what you can do, you can just cover all of your results. You can copy them here. You can go into Profis software, and you can click on import factor load, and you can directly paste it here by Control V. It is going to detect all of them with their perfect names and with their perfect values. You can also do the interchanging here also. If you don't want to interchange the values in the Excel, you can interchange the values here on by using this drop down menu. And you can also change the units from here. So I'm right now okay with this, all of these things. I am going to hit apply. So what it is going to do, onto the bottom, you can see, you can stretch this particular thing, or you can see the first load that was defined earlier by me by inputting the values. So it is also there, and all of this input combinations have been added automatically. So it is going to check the software for all of this, you can say, load. So let's try to analyze it. So you can do it from here. You can click calculate, and it is going to iterate it, and it is going to calculate all of the stresses, all of the utilization ratio. I'm going to let you know that the design is getting passed or not. Okay, so there are chances that it is not going to get passed in the first try. So what you have to do, you have to wait for it. You have to change the things. Like it totally depends on major things that if it is getting passed or failed. Okay, so at the start, it is going to let you know the component based finite element method anchor plate designs Starting, you can say the utilization ratios, that how much your anchors are getting utilized, how much load it is getting, and how much it is getting loaded up. You can see all of this basic analysis thing, that is deformation or the plastic strains. You can see it here. You can rotate them, and you can see the concrete stresses like that, and you can confirm it, that I'm going to confirm it. So it says that you are confirming that your plate is going to act like a rigid anchor plate. Okay, so we can just put okay on it, and onto the right, then we can see all the results. So if all of these are under 100%, that is all of, if all of these things are in a green portion, you can see that it is taking all the loads easily. But into the load bearing concrete, it is getting failed. It is not taking load. So what you can do, you can increase the size, or you can increase the grade of the concrete to take the more load, and like that, and then it can get passed. Apart from this, all of the things about the anchor, that is the tension, shear force, and the combination, the anchor plate, everything is getting passed. You can see on here also that the utilization ratios are very good. For every combination, it is getting passed. Okay, so for this one particular thing, that is load bearing, you can check out the thing. Okay, you can change the things by going backside, and the moment you are going to change anything from this side, these results will get deleted, and the calculation need to start from the start. Okay, so suppose we are getting passed at everywhere. Now we want to create a report. So you can click on create report. Now you can right now not add it in, you cannot add it, or you cannot customize some of the things in the free version. Okay, so let's just click save and generate, and your report will get generated. Okay, you can take this report, and if you're getting passed, you can give it to on your site, and you can just discuss it with a senior person or like that. Okay, so this is the report. This report lets you know about everything, that is what kind of design method, what kind of anchor you are using. Okay, what are the details of your drawings. These are the calculations of all of this particular thing, the tension force, shear forces, all the manual calculation that we usually do. And the good thing is, it also let you know about that from which table or from which section they are taking all of this design things. So they are using European standard, and they are using all of this design, and you can see how much this thing is. The weld and the plate calculations are at the down bottom here. This also let you know what kind of accessory you need in site at the time of doing all of these things. There is a thing in color red here, that is one of the load combination. In one of the load combination, the concrete is going to get failed, so we need to check it out. You can see the diagrams here, that how much stresses are there, how stresses are getting changed. All of this weld calculations are here, that if it's getting passed or not. Okay, like that. So fastening does not meet the design criteria. Why? Because this concrete is getting failed. So you can do the exercise with the concrete. You can increase its strength. You can make its size a bit greater, or you can reduce the loads which are getting onto the structure, and like that. So in this short tutorial, or you can say in the discussion video, what I have let you know, I have demonstrated a very good example of designing a base plate by using the anchor bolts with the help of HILTI Process Engineering Suite. If you have any question, or if you have any suggestion, please write me down into the comments, and I'll let you know what I can do for you. Thank you. Take care. Bye-bye.